Welcome to this video presentation of the laboratory activity on connecting a 4x4 keypad to an Arduino Uno. In this laboratory activity, we will guide you through the process step by step from setting up the hardware to uploading and running the code. Let's start from the program 1. So first, let's gather all the necessary materials that will be needed in this program. So we will have the Arduino Uno, and then search on the Tinkercad the 4x4 keypad, and then let's connect the Arduino Uno R3 to your 4x4 keypad. Pin 1 will be connected to the pin 9 of the Arduino. Pin 2 will be connected to the pin 8, and then pin 3 of the keypad will be connected to the pin 7 of the Arduino, and then pin 4 connected to the pin 6 of the Arduino. Pin 5 will be connected to the pin 5 of the Arduino. Pin 6 will be connected to the pin 4 of the Arduino. Pin 7 of the 4x4 keypad will be connected to the pin 3 of the Arduino board, and then pin 8 connected to the pin 2 of the Arduino board. So for that, let's ensure all connections are secure, and once done, connect the Arduino board to your computer using the USB cable. You should see the green power LED labeled PWR turn on. Next, open the Arduino IDE on your computer and let's enter the code. Type or paste the following code into your Arduino IDE. So this is the complete code. We included the keypad library, and then we also defined the keypad layout and pin connections, initialize the keypad, and wrote functions to read and display the key presses. So this code initializes the keypad and captures the key presses, which will be printed to the serial monitor.
Program 2. Arduino Jukebox. Write and design a musical jukebox, a menu-driven system running on serial monitor screen, using a keypad comprising 6 preschool rhyme songs, or any 6 songs of your choice. With the use of switches, the user can select song to be played by Arduino. Provide a running light pattern for each song and played as accompanied by the song being played. So here is my code for this program, and this is my notes for each of the songs. We also included pitches.h for my notes, and also a library for the keypad. So let's try it out, verify, and upload. Let's check the serial monitor. So let's try the first song. And let's flip the switch. And the second song. Flip. And the third one, I just keep the switch on. Fourth one. test. Thank you. That's it.
Program number 3 is a hexadecimal calculator. In here, we will create and design a hexadecimal calculator that can perform the following mathematical operations such as addition, subtraction, multiplication, and division. The mathematical expression formed from typing it via the keypad is being displayed over the serial monitor screen as well as the output of the said mathematical expression. Now here is my simulation using the Tinkercad. Here's my code and I will show it to you using the Arduino IDE. Now in this one, I defined the keys and assigned it the function I want them to be. So the A key, I assigned it to addition. The B, I assigned it to subtraction. The C, I assigned it to multiplication. And the D, I assigned it to division. And the pound sign, I assigned it to equal sign. And the asterisk sign, and the asterisk key, I assigned it to clear. So in this part, I defined the keys that I used in the Arduino. I defined the pins that I used in Arduino, and in the setup part, I initiated the serial monitor and printed hex calc ready. And in the main loop, here in the main loop, this continuously checks for key presses on the keypad. So if the asterisk key is pressed, that it is assigned to clear. So it clears the input string and prints cleared to the serial monitor. Then if the pound sign is pressed, it is assigned to the equal sign and it calculates the result of the expression stored in the input string using calculate function. It prints the result and then clears the input string. And here, in this part, for other keys, it appends the pressed key to input string and prints the current output. Here, it will this will show what input that I have input. Then it will calculate the result after I click the equal sign. Here's the result. Then in the next part, this part is the hexadecimal arithmetic functions. So this finds the index of the operator in the expression. It splits the expression into two parts, the operands based on the operator, and it calls the appropriate arithmetic function based on the operator. So we have the add, the subtract, the multiply, and the divide function. We also have the calculate. And then after that, we have the finding the operator. So finding the operator, it loops through the expression to find the first appearance of an operator. So it returns the index of the operator or -1 if no operator is found. So and the last part is the format hex. So this formats the result as a hexadecimal string using the printf. So here is the simulation of my program number 3. Now, if you press 12, then press the asterisk key, it should be cleared. Then if I press 15, then plus 3, it should be 18. Okay. If I press 65 minus 2, should be 63. Then 96 times 69, it's 3D86. Then 89 divided by 89 should be 1. So this is how it works in Tinkercad. Now let Albert demonstrate it using Arduino.
Now for the last part, program number 4, password-driven piezo buzzer. Design an Arduino circuit for a password-driven running LEDs. So the program will ask the user to enter a password. If the password is correct, it will buzz off the correct musical tone. So the musical tone we choose is the Nokia tone. And a running LED will light from left towards right. So that is if the password entered is correct. The LED will light from left to right. Otherwise, it will display an incorrect running LED pattern. So the LEDs pattern we integrate is by the groups of 2. Together with a sound off from the buzzer, different tones from the correct password. So later I will show to you the simulation and ask again the user to enter the correct password. So for this program, it limits the trials up to 3 for entering the correct password. And if the last attempt is still incorrect, the Arduino will disable the keypad and it will no longer be accepting any entering of the password. So here is our simulation using the Tinkercad. And for the code part, let me explain it to you in Arduino IDE format. So first, we define the rows and columns on the keypad. Next, we define the key mapping for the keypad itself, how it is placed in rows and columns. Next, we define the pins to connect keypad rows and columns to Arduino. And for this one, we define the pins for LEDs and buzzer. And for this program, we use the correct password 0813 and also attempt the limits. So only 3. This one is the melody for the correct password, which is the Nokia tone that we use, and no duration. For the setup function, initialize the LED pins and the buzzer pin and also the serial print line, which asks every time they enter password. So for the loop function, collect input from keypad until the length matches the password. For this one, every time we press a password to the keypad, it displays asterisk for each key press. So this is on the serial monitor. And for this one, we check if the entered password is correct. So if the password is correct, it brings the password is correct, and incorrect otherwise. The attempt is reached, the keypad will be disabled. So this is for delay for the next attempt. Correct pass plays a melody for the correct password, and at the same time, it lights up the LED sequentially. So the entered password is correct, the LED must light from left to right. On the other hand, incorrect pass displays a tone for incorrect password and it blinks the LED in 2 groups. For the simulation part, I'll be using the Tinkercad. So first, we enter the correct password, which is 0813. So as you can see, the LED lights up sequentially from left to right, and also the musical tone that we use, Nokia tone. How about we enter incorrect password? So you can see the LED lights up by the groups of 2. So that means the password we enter is incorrect. So we try again. Incorrect. So for the last attempt, incorrect. So still incorrect, and so as we can see on the serial monitor, max attempt reach, keypad disabled. So if the max attempt reach, it will no longer be accepting any password. So this is the simulation for this program. For the hardware part, here is the video.